Hey folks, today we're going to talk about work and energy, and this is just going to be an introduction. Um, and then the next video, I'll do some examples with you. I'll start with work and energy. It's kind of a tough topic, unlike something like force, where if I say what's a force, it's a push or a pull, and you can imagine doing that to something. You could push a bowling ball or pull a wagon. Energy and work, that's not like really a one sentence answer. And actually, if you look those words up, sometimes you'll see the following. Work is a change in energy, and energy is the ability to do work. That's not that helpful, is it? Part of what we're going to do is, in the examples, especially when you start doing calculations with energy, I hope that it'll make a little more sense. Um, and most of us have a rough idea of what energy is. One way to think of it is the amount of damage that something would do. So, for instance, if I had a bowling ball and I held it 2 feet off the floor and dropped it, it's going to do so much damage when it hits. But if I held it 5 feet off the floor and dropped it, it's going to do more damage. So that second bowling ball had more energy. Same thing if they're rolling. Let's say a bowling ball is rolling at 10 miles per hour. It's going to do so much damage when it hits the pins. But if the bowling ball is rolling at 30 miles an hour, it's going to do a lot more damage, right? So again, the faster bowling ball has more energy. And then another one would be like a rubber band. If I stretch a rubber band 1 inch and fling it at you, it's going to do so much damage. If I stretch it 4 inches and fling it at you, it's going to do more damage. So we have an innate sense of what energy is, but it gets a little tricky when you try to put it into words, okay? Something else that you need to know about energy, it doesn't just appear and disappear. It's always there, very much like water here on the earth. You got a lake, the water evaporates, um, and then it turns into rain and it falls back down. That water is always there. Same thing with energy. For those three examples, like the bowling ball, if you lift the bowling ball gets more energy. Where did it come from? Well, it came from the food calories that you had that day. Same thing with rolling the bowling ball. The faster you roll it, the more energy that takes, the more work you do. That energy comes from you. Same thing with stretching rubber band. Okay. Now, the equation for work, and this will be on your sheet, but work is equal to a change in energy. Okay. And that is equal to force times delta x. Okay. Now, let's talk about units for a second. You guys know that force is measured in newtons and change in x is measured in meters. So for work or energy, and they're both the same units, you could write Newton meters, but we have a different unit for that. We say a Newton meter, a Newton times a meter, that equals something called a joule, or just a capital J. So one way to think of energy and work, you can think of it as something valuable. Joules, are valuable, right? Okay. Now, work this equation tells us how much energy we've given or taken away from an object. So work is kind of like a change in energy. That's what it is. So for instance, let's say you and I each have $30 in our wallet, and I reach into my wallet and I give you $10. All right. Well, negative work was done to me. I've lost $10. On the other hand, you've gained energy. You've gained $10. Okay. So the work done on me would have been negative 10. The work done on you would have been positive 10. But notice the energy came from somewhere. It came from my wallet and it went to your wallet. So you can think of energy as a little bit like money in that respect. It's coming from somewhere and going to somewhere. Okay. The next video, we're going to do a whole bunch of examples using this equation. And one of the things we're going to talk about is that positive or negative. So for instance, for the wallet example, I lost money, that'd be a negative, and you gained it, that'd be a positive. Okay. So in the next video, you will want a calculator. We are going to do some calculator examples.